Hello dear students, hope you are doing fine and keeping yourself safe and healthy. Today through this video I am going to teach you a very important chapter in organic chemistry in class 12 science. The name of the chapter is Haloalkane and Haloarene. Before we start with this chapter, let us first try to understand what is haloalkane and haloarene. Halo stands for halogen. As we know, halogen is group 17 elements like fluorine, chlorine, bromine, iodine. Alkane is a compound of carbon with general formula CnH2n plus 2. That means for every n number of carbon, there will be 2n plus 2 number of hydrogen atom. In haloarene, halo again stands for halogen, whereas arene stands for aromatic compounds of carbon and hydrogen. Example, benzene, naphthalene, etc. Next, let us see how we get haloalkane from halogen and alkane. I will explain with the help of this reaction. Alkane, we know the general formula, CnH2n plus 2. And the halogen is taken in molecular form. That means if you are taking fluorine, you will write F2. If you are taking chlorine, you will write Cl2. For bromine, you will write Br2. And in general, is written as X2, where X can be fluorine, it can be chlorine, bromine, or it can be iodine. So what happens here is one or more hydrogen is replaced by halogen. So say if you replace one hydrogen with one halogen, you get this formula CnH2n plus 1x. And this is the general formula of monohaloalkane. If you replace two hydrogen with two halogen, you'll get dihaloalkane. So let us see the classification of haloalkane and haloarene. So the first classification is based on number of halogen atom. So let us take the first example. CH3Cl. So you can see there is only one halogen atom here in this compound. So it's known as monohaloalkane. So if there are two halogen atoms, so in this compound is known as dihaloalkane. If there are three halogen atoms, is known as trihaloalkane. So in this classification, we use the prefix mono, di, and tri to represent the number of halogen atoms. I'll take some more examples to explain this classification. So let us take this compound, CH3, CH2, Br. Now you can see here in this compound, you have only one halogen atom. So therefore, this is monohaloalkane. Another example, CH2, Br, CH2, CH2, Br. So in this compound, you can see there are two halogen atoms. So therefore, this comes under dihaloalkane. Similarly, the haloarenes are also classified based on number of halogen atoms. So let us see. So the first example, benzene ring with a chlorine atom. So you can see in this compound you have only one halogen atom. So therefore, this compound is known as monohaloarene. If you have two halogen atoms attached to the benzene ring, is known as dihaloarene. And if there are three halogen atoms, is known as trihaloarene. Next, let us see the classification based on sp3 hybridized CX bond. So under this classification, the first set of compounds we are going to study are primary, secondary, and tertiary. So let us see what is primary haloalkane. We'll try to understand the classification with the help of examples. So let us take this compound CH3CH2X, where X can be any halogen atom like F, Cl, Br, I. Now you can see the halogen atom is attached to this carbon, and this carbon uses sp3 hybridization. So that's how it comes under, based on sp3-CX bond. Now next, you can see this carbon is attached only to one carbon. So therefore, this compound or this haloalkane is known as primary haloalkane. So in simple word, if the halogen atom is attached to a carbon, which in turn is attached to only one carbon, is known as primary haloalkane. The halogen atom will be attached to a carbon, which in turn will be attached to two more carbon atoms. So this compound is known as secondary haloalkane, or 2-degree haloalkane. Is tertiary. So tertiary, the halogen atom is attached to a carbon, which in turn is attached to three different carbons. So this is an example of tertiary haloalkane. And tertiary haloalkane is also known as 3-degree haloalkane. So I'll explain this primary, secondary, tertiary with the help of more examples. So let us take the first example. So you have this compound CH3, CH2, CH2, Br. So now you can see here the halogen atom is bromine. Now this bromine is attached to this carbon, and this carbon is attached only to one carbon. You can see there is one more carbon, but there is no direct linkage between these two carbons. So this compound is primary haloalkane. Let's take the next example. CH3, CH, Br, CH3. Now in this compound you can see the bromine is attached to this carbon, which in turn is attached to how many carbons? Two carbons. So therefore, this comes under secondary haloalkane or 2-degree haloalkane. We can take some more compounds from the textbook and try to find out the nature of the haloalkane, like whether it's primary, secondary, or tertiary. So under the same heading, let us see the next set of classification, that is allylic haloalkane. So in allylic haloalkane, the halogen atom will be attached to a carbon which uses sp3 hybridization. But the carbon which uses sp3 hybridization will be followed by a carbon which uses sp2 hybridization. So we can say any haloalkane where the halogen atom is attached to sp3 carbon but is followed by sp2 carbon, the haloalkane is known as allylic haloalkane. I'll give one more example. So you can see in this compound, the halogen atom is attached to this carbon. And this carbon, you can see it forms only single bond here, so it uses sp3 hybridization. But it's followed by a carbon which uses sp2 hybridization. So this is an example of allylic haloalkane. Next is benzylic haloalkane. So in benzylic haloalkane, the halogen atom will be attached to a carbon which uses sp3 hybridization, followed by phenyl ring. So in place of this ring, we can also write C6H5. So this is an example of benzylic haloalkane. So once more, you can see here, the halogen atom is attached to this carbon which uses sp3 hybridization, but is followed by a phenyl ring. So such compounds are known as benzylic haloalkane. Next, let us see the classification which is based on sp2-CX bond. So the first classification is vinylic halide. So in vinylic halide, the halogen atom will be directly attached to a carbon which uses sp2 hybridization. So you can see the difference. Earlier we studied allylic. In allylic, halogen atom will be followed by sp3 carbon and sp3 carbon will be followed by sp2. Whereas in vinylic, the halogen atom will be directly attached to a carbon which uses sp2 hybridization. Next is arylic halide. So in arylic halide, the halogen atom is directly attached to phenyl ring. Thank you so much. That's all for today. We'll continue this chapter in the next video.